mint or body is dissolving some, and it's going down here to around the same as the alcohol came out, which I don't know about that alcohol. Anyway. Soap solution? Yeah. You guys probably had... How many people got their mouth washed out with soap at one point?
You did.
Yeah. I told you that story, I guess. I said, who is Mrs. Bigley? Mrs. Bigley, my kindergarten teacher. My rest of the soul. I said poop. I didn't know it was a bad word. Found out. Guess it is. If it was, I don't know. Nowadays, that would be pretty mild, I would think.
Oh, yeah. It's a noun.
Even for kindergartners, you know. I suspect those kindergartners have a lot more colorful language than that. Anyway, well, the soap, yeah, kind of greenish. It's not real. Tastes kind of bitter to me when I remember it back. but should, I would think so. A little bit basic, but it registers maybe just a little, like between 7 and 8. I probably could match up about on an 8.
You need to make it bitter so you can eat.
Yeah. It's still very unpleasant no matter what you do. Not something I would recommend you pour on your mashed potatoes or anything. Alright, so anyway, you can see there's just a lot of different pHs out there in the world, and if we take two extremes and pour them together, maybe just kind of work towards the middle and see what we get. So this was, oh, that looks like the strongest one.
You diluted down with water.
Did I? Okay, so
That's probably why it's
so if we pour these together, acids neutralize bases, and so they should come something towards the middle, right, when we pour them together. So see what happens.
Reaction. Or not.
You can see that, okay, I don't know if you guys, obviously that the base 1. Okay, so we'll put that on base is 1, acid's 0. Alright, here we go. Base and acid again. Watch what happens when they hit each other. You can see the neutralization reaction occurring.
Oh, nice.
So if I pour them all together, let's go ahead and...
Base 1 again.
Well, that's the problem. I don't have equal proportions. Yeah, and they also have to be about the same amount, which is also tricky. So, all right, let's see if I can do something with the alcohol. The alcohol is slightly... So, what was this one then? I can't remember now. I think that was borax.
Yeah.
Let's see what happens.
Oh, man.
It was green.
Disgusting. It formed curves.
Don't do that.
Hey guys, bottoms up.
It was disgusting. Okay, I'll go with that. Let's try it the other way. Here's candy juice, and I think this is actually the borax. I should have labeled these to get right.
It's not working.
Okay.
Hey, the candy stick.
Candy stuck to the thing. Alright. These are both about the same, so probably nothing to laugh at. Oh, it turned yellow. I was wrong about that. Okay. Alright, so... Alright, anyway. If you really wanted to do it right, you'd have to really carefully measure to get exact amounts of each to get the perfect utilization. Obviously, we didn't do that, so... But that's just a basic overview of pH acid-base stuff. And there's a lot of chemistry involved in that, but you know, at the end of our time together, so we won't get to talk about that. What?
Could you put some borax and hydrochloric acid?
And what do you think would? All right. And then check the pH of that, or what?
Yeah.
Okay. Borax, which is basically.
Because that's close to an extreme.
Hydrochloric acid. And what are you predicting is going to happen here?
I think it'll be more or less.
Probably the strong acid will probably win out. I don't know. Looks almost like neutral.
A little blue.
Yeah, it looks slightly basic. So the borax was the winner there. You know what we can do is you can just just overdose it with acid. And you can see the acid kind of gets a malty color, and then the acid killed it.
It looks like the cherry flavored candies.
Yeah, doubt it would taste that good. Highly recommend not eating more. Then if you want to see, then here's sodium bicarbonate, which is baking soda. Baking soda neutralizes acid, so we pour that in, stir that up, we should be able to kill off that acid. It'll turn white. Yeah, well, see it foaming, because that's CO2 being released. So we're neutralizing that, and eventually I should be able to get it turned over to.
So the reason like baking soda.
So that's what would be going on in your stomach, Take some baking soda and kill off the gastric juices, and then you burp because all that CO2 would. And then eventually the gastric juices would turn like basic. Slightly basic.
So in like a normal acid-base reaction, there really isn't that much of like any reaction. There's a gas being given.
Oh no, they don't have to give off the gas. Only the carbonates and bicarbonates give off gases in that neutralization. If you took NaOH and HCl and put them together, they would fight each other. I can show you that. They get a larger tube. Yeah, let's do it. It's kind of funny. This is like, if you want to do, okay, that's just regular water. That's from the tap. Let's see what that does. That's pretty much neutral. Okay. And then what you can do, well, just because of the and then if you want to make it all red, you just put some acid in, right? It turns all red, and you can see it. And it's kind of attractive. And then what you can do is watch the acid and base fight each other by putting a little bit of base in this, a strong base. And oops.
Base is winning.
I felt like it was going to break it.
Base is winning.
Okay, and there the base is a winner. And you can just go back and forth and do this. There's the acid. Watch the acid. You shake that up on it. A perfect situation is where you'd have them equal, and you'd have to measure using these tubes called burettes to do we call it titration, to measure it real carefully. And we do a lot of that actually. Yeah. Did that for. Anyway, okay. Why don't we come back to home base right real quick before we head